Hello, good morning. My name is Avinash, and today I'm going to demonstrate my project to you, and you're going to see how it works, and you're going to see its working, components used, and many things. So, this is my circuit, and as you can see over here, make it clear for you. This is the circuit, the IC for XOR gate, and I will be using this as a parity checker circuit, and this is the checker, and this is the no this is the generator, and this is the checker. This will generate the parity bit. This is basically an even parity generator. This is the even parity checker. Now I will demonstrate you the working of the circuit. So this is basically a 4 input even parity generator. So as you can see that we have 4 inputs in the first circuit. Over here you can see the 4 pins connected to the 2 input XOR gate and the 2 XOR gates on each side. So these 4 bits, right now you can see that I have connected these 4 bits to ground, means that there is no signal coming in, means 0 0 0 0. These 4 bits are basically ground. So as you can see, the LED does not glows. This is the generator, parity generator LED. This will not glow because in this generator is that when all the number of ones in the bits is even, this LED will not glow. But as soon as the number of ones become even or odd, the number of ones become odd, then what will happen, that this generator will generate 1. That means now the new code becomes like, for suppose we have given a code of 1000, right? So number of ones is odd. So what this circuit will do is that it will create another bit, that is 1, which will be added in the input bits. So now the input bits was 1000. After the output it will become 1001. Now the number of ones is even, and then and then what will happen is that the checker IC, this is a checker IC. Now what will happen is that the 4 input bits that we have given into the generator are being transmitted to the checker. Now the checker will check the 4 input pins and the inputs that are being transmitted from the generator, that is the number of ones even or odd. Right now it is even because during the transmission no bit is lost, right? So this checker will not indicate that indicators that there is no error, right? So let me demonstrate you another program in which, another circuit in which I will create a error. Okay, so now I've made some changes in the circuit, and as you can see that the light is glowing. This light is glowing because now what bits input the 4 input bits that I have given are these 0 1 0 0. So the checker will check that if the number of ones is even, so it will give 0, but right now the number of ones is odd, right? So it will give 1. So we are demonstrating this property into this circuit like this, that I have given 1 to this bit, so it is creating a parity bit. Now it's creating a parity bit. Now we will see that as we have seen this, the working of the parity generator, now we will see the parity checker. So here the transmitted bits are being transmitted to the checker, which is this circuit. In this circuit, as the transmitted bits are being transmitted, is this that 0 1 0 0 and 1, these 5 bits are being transmitted into the checker. That is why now the checker will check that if the number of ones are even, then it will not glow. If the number of ones are not even, then it will glow, because this is also even parity checker. So for suppose if this bit is lost somewhere, and now the input is this is the input in the checker, right? So let me tell you that what will happen is that this light will glow, indicating that there is an error in the transmitted bits. Let me demonstrate you. So as I was saying, that if this bit is lost somewhere due to some noise cancellation or noise effects or some other disturbance in the air or the medium, so what happens that in any case this one gets disappeared and this bit becomes 0, it makes change. So now what this checker will do is that it will check the number of ones in the transmitted bits. If these are odd, this will indicate us that there is an error in the transmitted bits. Right now I will demonstrate you the same thing, this code over here. For suppose this one is lost, so this one is lost like this one is lost. See, this LED is now glowing, indicating us that there is an error in the transmitted bits. So now this is working fine. Now as soon as I switch it back to the same old code that was transmitted to it, it will stop glowing. As you can see, it has stopped glowing. So therefore it proves that this circuit is working fine and has the capability to check and generate a parity bit for 4 input even bits. Thank you.